First, I need to explain some important terminology related to this section and just circles in general. The first is the word chord, and this refers to a line segment connecting 2 points along a circle's circumference. So one example of a chord could be, we have our circle here, and then there's one point on its circumference here, and the other point over here, and the line joining these 2 points is considered as a chord. Another possibility is the same circle but with 2 other points slightly lower than these ones. That's the one point and that's the other. In this case as well, the line joining these 2 points that lie along the circle's circumference would be considered a chord. Then for a third case, the same circle again, but this time with 2 points in a vertical line. So this time the chord would actually be a vertical line, but it's still fine. It doesn't need to be at a funky angle or anything. It can just be vertical or horizontal as well. Just as long as it joins 2 points along the circumference, then it's a chord. Then here's a fourth example, where again you have the same circle, but this time the points are a lot closer together. So the chord is a much shorter line than before, but still matches the definition, that being a line segment connecting 2 points along the circle's circumference. So this would also be a chord. And here's a fifth example. Now this line, on the other hand, cannot be considered a chord. This would just be some regular line that intersects the curve at 2 points. For it to be a chord, the entire line has to be within the circle. If any bit of it comes out of the circle, then it isn't a chord anymore. Then a pertinent question to ask is, what about the diameter of a circle? Would that be considered a chord? Yes, it definitely would be considered a chord. That's what the diameter looks like. And an important thing to note is that all diameters are chords. But the flip side of this is that not all chords are diameters. So just keeping these ideas in mind, I think you should have a pretty decent understanding of what a chord is. Then the next term for you to learn is the meaning of tangent. A tangent is defined as a straight line that touches a circle's circumference at only one point and never enters its interior. Here's an example of a tangent. This line would be considered a tangent because, as you can see, it only touches the circle at a single point and it doesn't enter inside the circle. Another example could be this line, which touches the circle at this single point and again doesn't enter its interior. Then just another example to drive the point home. This line, which the circle essentially sits on top of, but the line only touches the circle at a single point and doesn't enter the interior. So this also counts as a tangent. Then an important property of tangents, which we'll use to solve various questions, is the fact that the tangent will always be perpendicular to the radius of the circle at the point of contact. This is demonstrated in this diagram where the tangent touches the circle at this point, and then if you were to draw the radius from that point to the center, the tangent will always be perpendicular to the radius. And using this fact, if you're given the equation of a circle and you need to determine the equation of the tangent at a certain point C with coordinates of x1 and y1, you can determine the equation of the tangent using the following bunch of steps. First is, take the circle equation you're given and represent it in the same way as the general equation. Next, determine the gradient of the radius joining the center of the circle with coordinates a and b and the point C, which has coordinates x1 and y1, using the usual equation for determining a gradient, which is difference of y coordinates over difference of x coordinates, which in this case would be y1 minus b over x1 minus a. Then next, determine the gradient of the tangent using the fact that the tangent and the radius are perpendicular to each other. Therefore, the product of both their gradients will equal to -1. So rearranging to make the tangent gradient as the subject, you can get the tangent gradient by saying -1 over gradient of radius. Then it's just the final step, which is determine the tangent equation using y equals to mx plus c, then subbing in the tangent radius, which you just determined as m, and then for the x and y coordinates, subbing in x1 and y1, which are the coordinates for the point at which the tangent touches the circle, at which point you just solve for c, and then you can get the whole equation. Here's an example. The question asks, what's the equation of the tangent to the circle with the equation x squared plus y minus 2 squared equals to 13 at the point with coordinates 3 and 4. Then just follow the 4 steps I just outlined. The first of these being, represent the circle equation in the general form, and in this case it's already given in the general form. So I guess the only new information we can derive at this point is the coordinates of the center point, which would be 0 and 2. The next step was determine the gradient of the radius joining the center point and the point at which the tangent touches the circle. So the two coordinates of interest are 0 and 2 and 3 and 4. Then just calculate the gradient as usual, finally giving the gradient as 2 over 3. Then moving on to the third step, you determine the gradient of the tangent using the fact that the product of the tangent gradient and the radius gradient will equal to -1. So you just rearrange this to make the tangent gradient as the subject of the formula, where I just use the subscript t to represent tangent and r to represent radius. The radius gradient was determined as 2 over 3. And when you simplify this down, you finally get the gradient of the tangent as -1, 5. Then it's just the final step where you put this all together to determine the equation of the tangent. The starting point is the equation y equals mx plus c. And the x and y values you sub in are those pertaining to the point at which the tangent occurs, which is coordinates of 3 and 4 in this case. So those are the x and y values. Then m is just m of the tangent, which we found to be -1, 5. Then just sub in these three values into y equals mx plus c. When you solve for c, you get it as 8, 5. Therefore, the equation of the tangent is y equals to 8, 5 minus 1, 5x. And those are all the main concepts related to analytical geometry that you need to know. I'll finally just look at one slightly longer example, which is sort of the level of question you could be asked in a test or exam. Here it is. We're told that the line y equals to 2x cuts the circle x minus 1 squared plus y squared equals to 17 at the points S and T. Given these facts, the first part asks for us to determine the coordinates of S and T. So how I'll do this is, I'll pause now, then you should try and see if you can solve the question. Then I'll resume and post the full working, then go through it step by step. Pause now and try it out. Then here's the working. The first step is just to note down whatever you can immediately deduce just from the question description. And the first thing I see is that you can deduce the coordinates of the center point, which would be an x coordinate of 1 and a y coordinate of 0. So the center has coordinates of 1 and 0. Then go about actually solving the question, which is done just by simultaneous equation sort of solution, where you just take the fact that y equals to 2x for this equation, then sub in 2x wherever you have a y in this equation. So where you have the y squared, that's why you get a 2x squared over here. That simplifies down to that, finally getting 5x squared minus 2x minus 16 is equal to 0. Then this equation, it is possible to solve it by inspection, but since I personally prefer the quicker and easier way of solving stuff, I'll just use the trusted quadratic equation, which is this. Then just note what a, b, and c would be, where a would be 5, b would be -2, and c would be -16. Then just sub it into the equation, and you finally get x as 2 or -1, 6. Then you just calculate y using either this complicated circle equation or just a nice line equation, y equals 2x. So the y coordinates will just be double of the x coordinates. So where x is equal to 2, y is equal to 4. Where x is equal to -1, 6, y is equal to -3, 2. Putting it all together, coordinates of S and T are 2 and 4 and minus 1,6 and minus 3,2 respectively. And they didn't really give us any specific information related to which one is S and which one is T. So you could even have it the opposite way, where T would be 2 and 4 and S would be minus 1,6 and minus 3,2. Doesn't really matter, you just have to get these two coordinates as the final answer. And part B of the question is, what is the length of the chord ST? Pause and try it out. Here's the working. So the actual calculation is relatively quick. The main bit is just interpreting the question correctly. So they ask, what's the length of the chord ST? Meaning the line joining S and T. And from the actual question, we know that the line cuts the circle at the points S and T. So S and T represent 2 points along the circumference of the circle, and therefore the chord would represent the portion of the line y equals 2x that joins the points S and T. And once you've realized that, then you can just calculate the distance between the two using the basic distance equation. Then just sub in the x and y coordinates for the points S and T, and you finally get the length of the chord as 3,6 root 5. Then part C of the question is, what are the coordinates of the midpoint of the chord ST? Pause and try it out. Here's the working. So it's super simple. You just take the midpoint equation and just sub in the x and y coordinates of the points S and T, and you finally get the midpoint as 0,2 and 0,4. And the part D of the question is, determine the equations of the tangents to the circle at the points S and T. Pause and try it out. Here's the working. So I chose to go one point at a time. So I started with point S, then I followed the same 4 steps I outlined before, which you need to use to determine the equation of a tangent given a certain point. The first of those will just represent the equation of the circle in the general form, and it's pretty much already in the general form, so I didn't need to do anything there. So now I just move on to the second step, which was determine the gradient of the radius. So I used the coordinates of the center point, which we deduced at the very beginning as 1 and 0, and the coordinates of the point S. I got the gradient of the radius as 4. Then I determined the gradient of the tangent using minus 1 over gradient of radius, getting minus 1 over 4. And I just sub this all into y equals to mx plus c, finally getting the equation as y equals to 4.5 minus x over 4. Then I did the same for point T, and finally got the equation of the tangent at point T as minus 4.5 minus 13 over 16x. Then the fifth and final part of the question asks, what are the coordinates of the point U where the two tangents intersect? Pause and try it out. Here's the working. So it's just a basic case of solving two simultaneous equations, these equations being the two tangent equations we just determined. You just solve them as per usual. So you have the two equations. I chose to minus the one from the other, just cancelled out the y terms, leaving 0. These two added, giving 9. These two combined to give 0,5625x. Then I just rearranged and solved for x, getting x as minus 16. And then I solved for y and got y as 8,5. Therefore, the coordinates of the point U are negative 16 and 8,5. And that's everything related to analytical geometry that you needed to learn. Now, I'll just summarize everything we've covered in this video. First, I introduced the general equation of a circle, which is x minus a squared plus y minus b squared is equal to r squared, where a and b represent the coordinates of the center point of the circle and r represents the value of the radius. Then I introduced some new terminology, the first of which is the word chord, which refers to a line segment joining 2 points along a circle's circumference, an example of which would be this line. Then I described the tangent, which represents a straight line that touches a circle's circumference at only one point and never enters its interior, such as the line in this diagram. Then I outlined a sort of property of tangents, which is that the tangent to a circle will always be perpendicular to the circle's radius from the point of contact to the center of the circle, such as in this diagram. And lastly, I described how you determine the equation of a tangent to a circle touching the circle at a point C using the following steps. First, you represent the circle equation in the general form. Then, you determine the gradient of the radius joining the center point with coordinates A and B and the point of interest C where the tangent touches the circle. And third, you determine the gradient of the tangent using the fact that the product of the gradient of the radius and the gradient of the tangent is equal to -1. And since you just determined the gradient of the radius, you can rearrange and solve for the gradient of the tangent. And lastly, you just combine all this information and determine the tangent equation using y equals to mx plus c and the coordinates of the point of contact C. And that's everything.